In today's lesson, we'll be learning about volume. Here are the equations for the volume of a cylinder, sphere, and cone. Often there are two forms of an equation. As you can see here, there are two equations for the volume of a sphere, and there are two equations for the volume of a cone. In either case, they will give you the exact same answer. Another important thing to remember is that if there is no operation between numbers and or variables, that means it is multiplication. And pi is approximated to be 3.14. As you can see here, we have the equations for the volume of a square-based pyramid, a rectangular prism, and a triangular prism. The things I said in the previous slide applies to this slide as well. In our first example, we want to determine the volume of the cylinder to the nearest cubic unit. As you can see in the diagram, we've already been given the radius of the base, which is a circle, and the height of the cylinder. The equation we're going to be using is volume is equal to pi multiplied by r, which is squared, and then multiplied by h. At this point, we want to substitute in our known values. So I know that pi is 3.14. I know that the radius is 5. And I know that the height is 20. The thing you want to do is you want to simplify 5 squared. So remember, 5 squared is not 5 times 2. It is 5 multiplied by itself. The 3.14 is going to stay exactly the same. 5 squared is 5 times 5, which is 25. And the 20 stays exactly the same. So at this point, all you need to do is take 3.14 multiplied by 25 and then multiply it by 20. And if you do that in your calculator, you should get 1,570. Now, this is not a decimal, so we do not need to round it to the nearest cubic unit since it already is in the nearest cubic unit. And the units are centimeters. And because we're dealing with volume, it is centimeters cubed. In our second example, we want to determine the volume of a square-based pyramid to the nearest cubic unit. As you can see, we've been provided a diagram. We've been given the side length of the base, which is 3 meters, and the height of the square-based pyramid, which is 6 meters. I'm going to start by rewriting the equation for the volume of a square-based pyramid. So that is volume is equal to base squared multiplied by the height, and then divided by 3. Let's go ahead and substitute in our known values. So the base is 3, that's going to be squared, and the height is 6. And the 3 stays exactly the same. Now, it's important to remember that this is 3 squared. 3 squared is equal to 3 times 3. It is not 3 times 2. So we're going to square 3. 3 squared is 3 times 3, which is 9. And 6 stays exactly the same, and the 3 stays exactly the same. What we're going to do next is we are going to multiply 9 by 6, which is 54, and then it's going to be divided by 3. So 54 divided by 3 is 18, and the units here are meters, and since it's volume, it will be meters cubed. Therefore, the volume of the square-based pyramid is 18 meters cubed. In our third example, we want to determine the volume of a sphere to the nearest cubic unit. As you can see, we've been provided a diagram and we are told that the radius of the sphere is 5 centimeters. So let's begin by rewriting the equation for the volume of a sphere, which is 4 multiplied by pi multiplied by r cubed divided by 3. Next, let's substitute in our known values. So the 4 stays the same. Pi is 3.14. R is 4. And that is going to be cubed. And that is going to be divided by 3 afterwards. Now, 5 cubed is very similar to something that is being squared. So 5 cubed is really 5 multiplied by 5 multiplied by 5. So when you cube something, that number multiplies by itself 3 times. So let's go ahead and simplify that. The 4 stays the same, the 3.14 stays the same. 5 cubed is 5 times 5 times 5, and if you put that in a calculator, you're going to get 125. And the divide by 3 stays the same. Next, we're going to multiply the numbers in the numerator. So 4 multiplied by 3.14 multiplied by 125 is 1,570. And the divide by 3 still stays the same. So you're going to take that number and then you're going to divide it by 3. And that is ultimately going to give you about 523.3. But remember, we want to find the volume to the nearest cubic unit. So we're going to have to round this. That's going to round to 523. The units are centimeters, and because this is volume, it is going to be centimeters cubed. So therefore, we've just figured out the volume of this sphere, and it is 523 centimeters cubed. In our last example, we want to determine the volume of a house to the nearest cubic unit. However, as you can see, we have a house which is made up of two three-dimensional shapes. We have what looks to be either a cube or a rectangular prism on the bottom and a square-based pyramid on the top. So that means we're going to have to use 2 steps to figure out this question. But let's start by writing the equations which we are going to be using. I'm going to call the top shape shape A, and I'm going to call the bottom shape shape B. So the volume of shape A is going to be base squared multiplied by h divided by 3, because that looks like a square-based pyramid. And the volume of the bottom shape, which looks like a cube or a rectangular prism, is just length times width times height. So let's do this step by step. Let's tackle one shape at a time. Let's do the top first. So the volume of A is base squared multiplied by h divided by 3. At this point, all you need to do is substitute in your known values. So I know that the base of my pyramid is 2.9, and that is going to be squared. The height of the pyramid is 2.1, and I just divide by 3. Don't forget, when you're squaring something, it is multiplying by itself. So 2.9 squared is the same thing as 2.9 multiplied by 2.9. So if you throw that into your calculator, 2.9 squared, which is 2.9 times 2.9, is going to be 8.41. Then we're going to multiply it by 2.1, and then we're going to divide it by 3. So let's show you some of those steps. 8.41 multiplied by 2.1 is 17.661. I'm going to now divide it by 3, which is going to be equal to approximately 5.887 centimeters cubed. Next, I'm going to figure out the volume of the bottom shape, which is what looks to be a cube or a rectangular prism. And the equation for that is quite simple. And that is just length multiplied by width multiplied by height. So at this point, all you need to do is substitute in your numbers, which is 2.9 multiplied by 2.9 multiplied by 2.9. So if you put that in a calculator, you're going to get approximately 24.389 centimeters cubed. However, we are not finished. We need to figure out the total area of the house, which means we're going to have to take the roof as well as the bottom part of the house and add those numbers together. So let's go ahead and do that. I'm going to write the total volume is equal to 5.887 centimeters cubed plus 24.389 centimeters cubed. And if you throw that into your calculator, you are going to get 30.276 centimeters cubed. However, we want to round our answer to the nearest cubic unit, so that just rounds to 30 centimeters cubed. So there you have it. The total volume of this house is 30 centimeters cubed.